Hello students, so let's move on to our next question. Okay, I'll leave this 11 and 12th one. Okay, done 12th one question. Okay, the same question, same type of question I've done. Next is question 13. Okay, if A is given, you have to show that the equation is given a square minus 5a plus 7i equal to 0. That is, we have to prove it equal to 0. Okay, and then you have to find A inverse using that equation. Okay, so let's start. A is given 3 minus 1 1 2, and you have to prove a square minus 5a plus 7i equal to 0. Okay, so first you have to find out a square. So a square is a into a. So 3 3s are 9 minus 1 3 minus 2 minus 3 minus 2 minus 1 4. So we'll get 8 minus 5 to 1 3. Okay, so this is your a square. Now substitute this in the equation which is given. So a square minus 5 into a. So I'll multiply 5 inside a. 15 minus 5 10 plus 7 into I. So 7 0 0 7. Okay, with identity matrix you have to multiply. So this will be 8 minus 15 plus 7, then 1 minus 5 plus 0. This is 5, I think. Three ones are 3, 2 plus 2 is 5. Okay, so this will be 5. Then minus 5 plus 5 0. 3 minus 10 plus 7. So this comes to 0 matrix. Okay, so we have proved this. Now you have to prove your A inverse. A inverse you have to find out. Okay. So first you write down the equation. So multiplying A inverse. Okay, so this will be A inverse A into A minus 5 into A inverse A plus 7 into A inverse I equal to 0. Okay, so A inverse A is I, this is also I, so you'll get AI minus 5I plus 7 A inverse equal to 0. Okay, so these two terms you can take that side. So A into I is again A. Okay, so 7A inverse equal to 5I minus A. So put values of your this identity matrix 5 0 0 5 minus A is 3 minus 1 1 2. Okay, so you'll get 5 minus 3 2, 0 minus 1 minus 1, 0 plus 1, 5 minus 2, 3. So this is your 7A inverse. So your A inverse will be 1 upon 7, 2, 1 minus 1, 3. Okay. Let's solve question 14. Okay, here they have given matrix A. Okay. You have to find numbers A and B such that they have given the equation A square plus A into A plus BI equal to 0 matrix. Okay, so you have to make use of this equation. First you find out A square. Okay, 3 3s are 9 plus 2, 3 2s are 6 plus 2, 3 plus 1, 2 plus 1. So we'll get 11, 4, 8, 3. Okay, so this is your A square. Substituting in the equation, you can write 11, 3, 4, 11, 8, 4, 3 plus A into A. So this becomes 3A, 2A, A plus B into identity matrix. So B 0, 0, B equal to 0 matrix. Okay, now write down the equations. Okay, so this will be 11 plus 3A plus B equal to 0, 4 plus A plus 0 equal to 0, then 8 plus 2A equal to 0, and 3 plus A plus B equal to 0. So from this equation you will get the value of A. So A is minus 4. Okay, that you can substitute in equation 4. So 3 minus 4 you will get minus 1. Okay, 0. So B is 1. So you will get A equal to minus 4 and B equal to 1. Okay, let's solve question 16. Okay, it is, they have given the matrix A. Okay, and you have to verify first. Okay, verification part you can do, and then you have to find A inverse. So to verify, you have to verify A cube minus 6A square plus 9A minus 4I equal to 0. Okay, so first you have to verify A cube. You can find by, first you have to find out A square, that is A into A, and then you have to multiply that A square with A. Okay, that will give you A cube. Now to find A inverse, you have to multiply this whole thing by A inverse. So this will be A square minus 6 A inverse A into A plus 9 A inverse A minus 4 A inverse I equal to 0. So A inverse A is I, so A square minus A inverse A is I, 6A, 9I minus 4A inverse equal to 0. Okay, so this equation you have to use, that is 4A inverse you can keep this side and all the other things goes that side. So minus plus minus plus. Okay, now you have to substitute value of a square, a, and identity matrix. Identity matrix is 3 by 3. Okay, so this you can do. Question 17, which is MCQ. Okay, let A be a non-singular square matrix of order 3 by 3, then adjoint of A. Okay, mod of adjoint of, mod means determinant of adjoint of A is equal to. Okay, so for this you have to use properties, that not properties, the theorems which we have learned. Okay, that is adjoint of A equal to n minus 1. Now they have given it to be order 3 by 3, square matrix of order 3 by 3, right? So your n is 3, correct? So adjoint of A equal to A 3 minus 1, which is 2. Okay, so answer is B. For next question, that is question 18. If A is an invertible matrix of order 2, then determinant of A inverse is equal to. Now it is invertible, it is given, so determinant is not equal to 0. So okay, so the equation is A inverse equal to I, correct? Taking determinant of this, we will get this. Okay, so A inverse equal to I, then using the property of determinant, that is theorem, you can write A into determinant of A inverse equal to 1. Okay, so determinant of A inverse is 1 upon determinant of A. Okay.